Hi students, welcome back to our chemistry class. In the last class, we learnt about the experiments and observations of Sir Humphrey Davy, Michael Faraday and J.J. Thomson. Today, we are going to discuss about the contributions made by Ernest Rutherford and James Chadwick. Let us start the class. The discovery of electron energized the search for other particles in an atom. Even though the presence of positive charge in a substance has been identified earlier, it is Rutherford who proved it authentically. Rutherford conducted an experiment by passing positively charged alpha particles through a very thin gold foil. Alpha particles are positively charged rays which are emitted by a strong radioactive substances. What is the speciality of gold metal? As you know, the gold is the most malleable metal and you have learnt about the malleability in 8th standard, right? So, what is malleability? Malleability is the property of a metal that can be beaten into thin sheets. The alpha rays that come out through the gold foil were allowed to fall on a circular photographic plate. Children, let us see a video showing the demonstration of gold foil experiment. Say, Rutherford and his co-workers performed the experiment in which alpha particles were allowed to strike a very thin gold foil. A screen is coated with zinc sulfide was placed behind the foil. Several alpha particles were used for this experiment. Whenever an alpha particle struck the screen, a tiny flash of light was produced at that point. From this experiment, he made the following observations. 1. Most of the alpha particles passed straight through the gold foil. 2. Some alpha particles got deflected through the gold foil by a small angle. And third point, some alpha particles got deflected by a large angle. Based on the observations, Rutherford made following inferences from his gold foil experiment. Number 1. Since most of the alpha particles passed through gold foil without any deflection, most of the space inside an atom is empty. 2. Very few minute particles suffered a deflection from their path. This means the positive charge occupies very little space inside an atom. Third and final point. There is a small part inside the atom where all the positive charge is concentrated. The central region of an atom is called the nucleus. The particles that were responsible for the positive charge are protons. Its charge was found to be equal and opposite to that of an electron. It is determined that mass of a proton is equal to the mass of a hydrogen atom. So, did you understand the contributions of Rutherford? Next, we will learn about James Chadwick. It was experimentally proved that there are neutral particles having mass equal to that of proton. This chargeless particle is called neutron. The total mass of an atom is concentrated in the nucleus because the particles proton and neutron that possess mass are in the nucleus. Atoms of all elements are made up of the particles, namely electron, proton and neutron. The difference in the number of these particles make an element differ from each other. So, let's consolidate the fundamental particles present in an atom, that is, proton, electron, and neutron. First point, the charge of the proton is positive, and for electron is negative, and for neutron is chargeless. Second point, the mass of proton is equal to that of a hydrogen atom, and mass of electron is very less than hydrogen atom. And for neutron, it is equal to the mass of a hydrogen atom. Here, the mass of proton and neutron have equal mass to that of a hydrogen atom, but the mass of electron is negligible, hence it is not considered. Third point, the position of proton is seen inside the nucleus and electron is seen outside the nucleus and neutron is seen inside the nucleus. Did you understand? Okay. There are electrically charged particles in an atom. Negatively charged electron and positively charged proton, right? But the presence of electric charge has not been felt to atoms or to the molecules made up of atoms. Why is it so? Since the number of positive and the number of negative charges are equal, an atom is considered to be electrically neutral. So children, let's summarize what we learned today about the observations and inference of Rutherford gold foil experiment, then discovery of neutron by James Chadwick, features of fundamental particles like electron, proton and neutron in an atom, and the reason for an atom is said to be electrically neutral. I hope you understood the concept that you learned today, and thank you for watching this